Our poll question asked us about accuracy and precision, and accuracy is how close you are to being correct. Precision is how close your measurements are to one another, not necessarily the correct answer. So one example of this, or a good demonstration of this, a good model of this, is a bullseye on a dartboard. When you shoot darts, you try to hit the bullseye. If you can hit the bullseye with 4 darts, your darts were both accurate, they hit the bullseye, and they were precise because they all hit the bullseye. But in example B here, if they can be precise without being accurate. Notice the grouping of the darts, but not on the bullseye, right? So that would be precise, but not accurate. And then the last example, where the darts are all over the place, that would be no accuracy and no precision. Where do you think your numbers were when you first started measuring in here that first day? Where were your measurements? Do you think you were accurate and precise? Oh.
Yeah.
Okay, we'll see when we analyze your data on Monday. We'll see where you were even after our discussion of sync things and measure. I would imagine that most of us were probably around 80. You probably had pretty good precision because you might have done it the same way every time, but you may not have been accurate because of your technique. One last thing to consider is something called percent error. And this is a nice, easy, simple formula. You take whatever you get in the lab, your experimental value that you measure, you subtract the accepted from that, and you divide by the accepted, and you multiply by 100, and that'll give you a percentage. So for example, if a student measures the mass and the volume of a substance and then calculates density as 1.40 grams per milliliter, the correct or accepted value of the density of that material was actually 1.30 grams per milliliter. What will the percentage error of that student measurement be? Well, if we use that formula, we plug in our numbers, we get 7.7% error. Notice that the percent error is a positive number. What does that mean? What does that tell you if it's positive?
You're over.
Right, you went over the expected, right? What if it was negative?
Then you were under.
Then you were under the expected, right? In this class, you will most likely have a negative percent error. You will most likely be under what the expected value is. Okay? Why do you think most of the time you'll be under?
I guess when you see on the measurement fluctuate a little bit, might start to go lower now.
Well, yeah, it's going to be due to error, right? Remember we talked about that yesterday, that every measurement has a little bit of error, and you're never going to be right, perfect on the number, right? Your tendency is to underestimate things. That's just the way it's been in the past, and usually we underestimate. Okay, so all measurement has some bit of error, and there are 3 ways that we can control error. First one, skill of the measurer, right? What do we call that?
Our abilities.
That's your human error, right? And we don't want to say that we have human error, because what does that really say?
We're calling ourselves stupid.
Yeah, you're kind of saying that I don't know what I'm doing in the lab, is what you're saying, right? So that can be remedied by knowing what to do in the lab, right? Practicing the skill, reading about how it's supposed to be done, asking your instructor, that kind of thing. What about conditions of measurement? How can you control those things? How can you control the conditions of measurement?
Like if your test tube is already big and you can't take off as much water as you could, and you can't about it.
Okay. What do you do? What does every experiment have that you have to do? Okay, control groups, but what else? Controlled what? Controlled variables, right? Things like having all the measurements being taken at the same temperature by the same equipment, right? You wouldn't want to measure the mass with one scale, then measure the mass with another scale, then measure the mass with a different scale. You have no consistency there. So you have not kept the conditions of the measurement controls, right? So there's techniques that you can do. Use the same instrument. Have the same person make the measurement so that they are consistent, right? They'll do it the same way every time. Okay, so variable control of variables. Measuring instruments. Is there anything you can do about that?
We can do it to an extent. You can, like the example you gave for the testing with water already in it. Yeah, we can just take off all the water as much as we could, but we take it all out.
Okay, but there's one way that you can control the error with measurement, with a measurement instrument. You think of it?
Have no difference.
Yep, you can make sure your instrument is in good condition. That's true, but really, the decision to choose the right instrument is the only control you can have. Really, every instrument has inherent error in it, but if you choose the right one for the job, you'll minimize the error. Does that make sense? Yeah. Okay. Now, the rest of this PowerPoint has all of the rules for significant figures, which we have already discussed. Okay. Also, in the rest of this PowerPoint are the rules for the significant figures of answers when you either add and subtract or multiply and divide, which we are going to practice here right immediately after this lecture. Okay. The reason I've chosen to include these things in the PowerPoint is so that you can go back and review these. I'm not going to go over them right now. We're going to go over this in a different format. Okay? But I'm just going to advance through these. And if you notice, these are step-by-step instructions on how to do these problems. Okay? I am also going to give you step-by-step instructions in the form of a video. There will be 4 different videos. One for adding, one for subtracting, one for multiplying, and one for dividing. Okay? One last thing to talk about here is direct proportions versus indirect proportions, or inverse proportions. A direct proportion means when one value goes up, the other one goes up, such as mass and volume. That's a direct proportion. The opposite of that would be something like an inverse proportion, where when one goes up, the other one goes down. Okay? An inverse proportion. That's it. That's all the direct versus inverse. So you should be able to refer to those or recognize those in those terms. Okay?